Okay, so we are back. All right, so like I said, so with the first aspect, when we are performing the Taylor diagram, that seems to work well. But then one thing I observed was that when you start computing the error sort of, I don't know whether it's only so for multiple file error computation, but you notice that it reverses the error plot. So where you are rather having overestimations tend to show underestimations instead. And so what we observed was you just need to, while formatting the file, just you need to change your observation and then your forecast. And once you do that, I mean, it would fix it back appropriately for you. Okay, so we do that and then we pass out into a CSV file, and then the error out for the error diagrams into another CSV file. But we precede the station name with, say, ERR underscore, which is the error underscore the station name. Okay, so once we run this, it produces all the files for us. And of course, if I should list my files, you should see the error files in here. So we have the error Kumasi Tamale Tema, and then there's the actual Tamale Tema, and then Kumasi for the Taylor series that will be producing. Okay, so now after doing that, what we want to do is when I pick this location, so when I pick my locations, all right, these are all the locations. Now, if I check the data type, this is a list, all right? So as a list, let's see, I think, oh, sorry. Okay, so I can create a copy of this using the np.copy. And then with this, I can easily, pick, say, the first column as all my stations, all right? You can do it this way or just transpose this and select the position 0, and that'll be for all the stations. So now if you have this, and I'm saying, okay, say for D in all these, just print D. This will print the stations one after the other. Okay, we can also use a one-liner approach and say, okay, just produce D for wherever D is equal to this, and that's all. Okay, now when we have this, with this as a string, we can also just have the string start point. Okay, so this means we are going to space the files with just single spaces, and then we join all these lists, the list that's created here. We are going to join them together. So just by joining this, then put all the files together, right? Then what we are doing is we want to be able to call this one time and then just pass that into the plotting file, because when we are plotting, we pass all the names in here. For instance, like what we did up here, we just pass in all the names directly. And so this time as a list, we can equally use the .join method, and then we pass all of them together. Without a single space here, it would just be placed together. So we just use a single space to space them out. Okay, and then of course that's what we have. Okay, and so we do the same for the error files, and that would give us our error files name as well. Okay, so once we have that done, it means our files here will be the files for the Taylor diagram, error files will be the error files for the error diagrams, and then we have marker sizes of say 10, and then the marker themselves of say circles, want circular markers. All right, and you can set a whole range of markers though. I mean, once you get used to the package, it becomes easy to work with. All right, now we are creating the fig and axis from the plt.subplots. We specify 2 columns, the figure size, and like I said, you can create your grid spec underscore keywords and set the ratio. Now these are 2 columns, so 2 columns are separated by width. So I can indicate the width ratio. That means the first plot should be, if these are a ratio of say a total of 5 inches, then the first should be 3 inches, and then the second should be 2 inches. That means the first should be, of course, bigger than the second. All right, and so think of it this way. Let's just have a sample plot here, and then we run this. Okay. I notice that the first one is bigger than the second, and that's what the width ratios will do. So if I have say 1 to 5, it means, of course, the first one will be smaller as compared to the second. Right? And so you can use all these keywords for formatting your plots and all that. Once we have that, we also create a subplot adjust, and we indicate that the bottom should start from 0.3 of the whole sheet, because of course I want to place my legends below. Okay, and then we take the first axis. Now we produce our verif file. So we invoke the verif, passing the files from here. And I told you, because there's a command line, we proceed with the dollar sign. So dollar files, or you can just have dollar into curly brackets files, and that also works. And then the method of Taylor diagram. Then we should save that to the file taylor.png. All right, and then if I need legends, I would need to show this, but then currently I don't want this to have a legend. I don't want the Taylor diagram alone to have a legend, so I set the legend to 0. All right, and then I indicate the markers. The MA should be these markers, that's the circular markers. The MS should be the marker size, and then the line color. So since I'm dealing with 3 stations, I want to give them all different colors. So there's red, blue, black, and then of course I added the 4th one, but that wouldn't be used for anything. And then the file size should be 10 inches by 8 inches. It should be saved to the file taylor.png. Okay, we already have saved it here, so I mean there was no need bringing it again. All right, so once we save that, it goes into the taylor.png, and we can use the mpimg to read that png file and plot it into the axis we had. Okay, and we give it a title, say A, and then we set the axis off. Once we do that, we can also use the same verif now into our axis 1. We call the error files. We use the same approach. We set we can set our y limit and x limit. And if you're not sure of what your limits would be, you can take those ones off for now. So you've seen them, and then you can set the limits. Also your line color, your file size, and where it should be plotted to. So this error.png. When we are done, we call the error.png, and then we produce that on the axis 1, and we set the axis off. All right, and that is enough to give us our plot. Okay, just this is enough to give us our plot. But then we didn't have the legend, because for all of them we indicated that there should be no legends. Okay, so I want this to be done running, and then when it's done, I'm going to bring on board these extra arguments so that we understand what that does. Okay, all right, and so that's our plot. So for the 3 locations, this is what we have, and then these are their error diagrams, or their error assessments too. Okay, and then you can see clearly from here. Now the blue and the black are showing overestimation. So you see that the blue is above the yellow line, the black is also above the yellow line. But if we hadn't reversed them, what you'd have seen is that instead of this, when you see the 0 mark, the blue and the black would have been lying below it. They would have been lying under this black line. And then you notice that the red is somehow closer to the orange line. In fact, because it's so zoomed out, we can't see it. So that shows, I mean, how close that is in terms of its width to the, I mean, the black line, and of course also your other error margin. So those are some of the tweaks you would have to understand in order to use them. So like currently we don't have the color bars or the legends, so we want to include that. So what we would do is we will just we use the patches. So we just create dummy colors. Now the colors I'm creating is, we have the same red, blue, black, okay, and I just added a green. But what we will need is, we want to add the orange for the observation, this orange line. So we just set the colors orange, red, blue, black, and that's enough. And then Y labels should be the locations. This should actually be the locations, the copy of the locations transpose 0. So yeah, but that's kind of still works. Okay, so we might not even necessarily need the Y labels in here, I believe. Okay, so let me take that one out. So we are only creating dummy or labels from here. So we take the locations, we create a copy of the locations, transpose them, pick the 0 column, which is only the station names, change them to a list, and then we have that as our P. Now, if we do this, run this up here, notice that it produces P would be just the station names. Now this as a list means we can insert an element anywhere. So P dot insert, and then I'll specify where to insert and then what to insert there, right? So let's say this index 0, that means the 0th element should be having something fixed there so that this will move to the right a bit. And so once we do that, we insert just the observation because we want the orange color to be the observation, right? And then we now create the handles. So all we are doing is we do blank scatter plots. We are plotting blanks and we set the colors to the same, all these colors. But bear in mind, we are doing this for an enumeration over the P, right? When you take time to understand it, it's quite easier. So we don't want to, we are just thinking of it as, okay, we've already generated the verif, but I want to just create some dummy plots that do not have any data, but then we want to just make use of the colors to create the labels. All right, so for any of the points P, we create these blank plots, and then we use the colors that are representing their particular index, and then we set the same markers for all of them. The edge color should be black, the line width should be 0, so no line width. And then we are saying that if x is greater than 1, that means for the elements or the stations, since we've inserted the observation as the first point, so if x is greater than 1, then it means we are looking at, say, Tema, Kumasi, and then Tamale alone. And then the one that's greater or equal to 1, so from 1 onwards, that will be Tema, Kumasi, Tamale. And then the 0 will be the observation. So for the Tema, Tamale, Kumasi, we are just going to use the same plot to create the legends. So those will just be circular markers. And then for the alternative, which is the observation, which is where x is equal to 0, we create a 2D plot, just a square marker, and give it a color orange, and then the line width of 0. And then this will just produce a plot. So let's see if this would give us any tangible output here to explain it. Okay, let me just change the colors here to say all red, and then change the markers to circles here. Exactly. You see, this has created a plot, then there's nothing showing on it because the plots are blank plots. Okay. Okay, sure. All right. So, okay, so these are just blank plots, but then of course we see clearly that the 0th element created a line 2D plot because of the line 2D plot we gave. The other one created like sort of collection plots based on the scatter plots we created. And so these we've assigned to the keyword handles, which of course we can pull them back from the handles and use them to create the legends. Okay, so we assign these to the handles. And then now we go back to the figure environment itself, which is the fig that we created. And we set the legend. And in the legend, we set the handles to be equal to these handles that we've created. All right. And then the labels should be all the labels P we currently have. And then we just, scale our markers and then indicate the number of columns they should be. All right. By default, the columns will just be one. The legends will be one column. We can specify them to be, say, 3 columns, 4 columns, whatever you want. And then the B box to anchor just shows, okay, where do we really want to place our color, sort of our legend. Okay, so this is just saying that place this on 0.5 from the X. So think of it as this: you have an A4 sheet, from left to right is 0 to 1, from bottom to top is 0 to 1. So place this on 0.5 from the X. That means place this in the center of the X, and then place this on 0.395 on the Y. That means closer to the bottom, but a bit away from the center on the Y. And then they should have, the legend should have an edge color of red, and then a font size of 12, and that is enough to just show a plot. Oh, come on. I should have commented this. Okay, let me just stop this because we've already run the verif. So it's already started. Okay, let's hope it didn't overwrite it. So I'm going to comment this since we've already run that, so that it doesn't take any longer time. All right, exactly. So we already have this generated. So that is it. And then the error, and then we now have a legend showing beneath it. Okay, And so, I mean, once you take time, you go through it. If there's any issue, you can always get back to us and we'll be able to respond to you. If there are questions, I'll take them now. But this is all for today. If there are any questions, I'll take them now and then. Yeah, we can call it an end to the session 3. Please, any questions, you can unmute yourself and then ask your questions if you have any. Yeah. So if you have any questions, you can unmute yourself and ask, or you can also type it in the chat. It's allowed. All right, so since there are no questions currently, we would bring today's session to an end. We've already exhausted our time. But then if you have any questions, you can leave them on the MeteoData page and the team would always respond to you. Do have a wonderful time and then hope to see you for the very final session next week. And thanks for honoring our, webinar sessions and see you later. Bye-bye.